Do you remember that picture? At first glance, it seems like nothing, but it means more than anything else in this world. A thin blue dot resting on a sunbeam. The words of the great man, Carl Sagan, about that picture must have been etched in our minds forever. Look there. That is that place. That is our home. That is us. Everyone you love, everyone you know, everyone you have ever heard of, every human being who has ever lived their lives on that piece of land. That one picture was enough to remind us again and again how small we are in this vast universe and how precious this little home of ours is. After that picture, those eyes close forever. But just imagine. NASA is saying today that it is disappointing and at the same time very impressive. I think when we open our eyes, when we turn on the camera, all they see is nothing, just pitch black darkness. Not because there is nothing to see, but because their eyes were deliberately closed forever 30 years ago. It was not an accident, it was not a failure. That was a brave decision, a sacrifice. To understand that, we need to understand one thing. The Voyager mission is not one, it is two. It is a big story in two parts. The first part was about seeing. It is over. Now we are seeing the second part of it. It is not about seeing, but about touching and hearing. On Valentine's Day in 1990, Voyager 1 circled around in the darkness from the edge of the universe and looked back at its home, Earth, for the last time. Then it took a heart-wrenching photo. After that, it was taken from the control room. It was not a single command to go billions of kilometers away and just turn off the camera with that command. It is very simple, you can turn it on any time, but that was not the case here. The first and most important problem that happened was the power of those probes. These probes do not operate using solar power. There is no panel. If you look at the picture, you can see that they are standing very far from it now, so if there is sunlight, they cannot do anything. Their operation is done by the radioactive substance called plutonium, which slowly decomposes and creates heat. These nuclear batteries had a power of about 470 watts at the time of launch. That is, there is no old yellow light in our house. It has the power to light 3 or 4 100-watt lights. But these batteries will continue to deteriorate over time. Every year, about 4 watts of power will decrease from the total. We can predict this gradually, even if it is completely charged. The camera is a device that uses a lot of power. More importantly, it will also need a heater to keep its instruments from freezing in the extreme cold. So the camera and heater are actually a luxury. We need to save every drop of power that Voyager gets to survive that long cold night among the stars. We need to redistribute power to the plasma detectors and cosmic ray sensors that help us sense the void. But there is another reason for the second decision that has forever sealed this decision. In order to save precious memory on the spacecraft's aging computer, engineers have turned off the camera. It is not like just turning off a light. It is like pulling out the entire wiring of that device and erasing the blueprint of how it worked. What happened here is literally deleting the code. Even if we had all the power of the universe, or even if we could send a new software there, it wouldn't matter. Because there is no computer today that can decode those images from the 1970s. They are all junk or museum pieces. Now, at the end of 2025, Voyager 1 is 169 times the distance from the Earth to the Sun. From that immense distance, our Sun, the center of this solar system, the source of life, can only be seen as a star. Yes, it is the brightest star in the sky. It is very small in size, but it is just a point of light that receives the light of a single moon. It is just one of the thousands of stars scattered in the sky. The constellation that we always see, the Sun, is not there. The light that reaches the spacecraft, as I said, is only the light on a moonlit night. So our Earth or Jupiter cannot be seen at all. They are completely invisible, like a forgotten dot drowned in the light of the parent star. It is the greatest fulfillment of the pale blue dot concept, not only for our world, but also for us. The concept of the solar system itself seems so insignificant, but the rest of the view is a vast view of the universe. It will be very beautiful. The Voyagers are now passing through the heliosphere, which is a big bubble that our sun has blown up. Inside this bubble is the wind and dust from the sun. Inside this bubble, there is a slight glow due to the light reflecting off the dust particles, which somewhat obscures the true view of the galaxy, but without the haze of the Voyagers, we can see our galaxy, the Milky Way, crystal clear, without a single speck of dust. We can see the same galaxy painted on a canvas of black with greater clarity and stillness. This new mission is now known as the Voyager interstellar mission. It is in its final stages. The 2025 period that scientists have been talking about for decades is not a future event. We are living now. This is the beginning of the end. In 2024 and 2025, researchers began to turn off many important instruments. In September 2024, the plasma science instrument on Voyager 2 was turned off. That is a great loss, because the same instrument on Voyager 1 was out of service in 1980. So it was the only instrument that had ever directly touched interstellar matter for decades, and its speed and temperature had increased. That sense of touch is now gone forever. In February and March 2025, the other instruments on both spacecraft were turned off one by one. So the sensors are shutting down one by one, and yet they keep flying forward. Voyager 1 is now hurtling through space at a speed of more than 61,000 kilometers per hour, more than 25 billion kilometers away. A little closer, Voyager 2 is traveling at a speed of 55,000 kilometers per hour, 21 billion kilometers away. They have been traveling like this for 48 years. They are still trying to talk to us. So how is this possible? The answer lies in a moment of luck and a masterpiece of engineering. The reason for the mission is a planetary conjunction that only happens once every 175 years. In the late 1960s, scientists realized something. The giant planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, were about to line up in a special way. This rare conjunction meant that a single spacecraft could visit all 4 planets. And that too, using a technique called gravity assist, a beautiful trick. When flying past a planet, it uses its enormous gravitational pull to launch itself from a cliff to the next planet, like throwing a rock from a cliff. Without this technology, a direct trip to Neptune would have taken 30 years without burning a single drop of fuel. The encounter between these planets took just 12 years. When we say Voyager 2, it is because the second probe was the first to be launched, and that too, 16 days later, on September 5th, 1977. Voyager 1 was launched, but Voyager 1, which was launched second, was the first to reach Jupiter. It overtook its twin, Voyager 2, on December 15th, 1977. Voyager 2 was deliberately sent on a slower, more complex path because the only way to get to Uranus and Neptune after Saturn was through that complex route. Voyager 1 was sent on a faster, easier path. This was done to ensure that the main objectives at Jupiter and Saturn were met. That is, NASA sent the riskier but more rewarding mission first. It was called Voyager 2. Then, to complete the main objectives, it sent a faster spacecraft after it and overtook it. This was a masterful risk management game played by NASA at the level of space. Now, the scientific discoveries made by Voyager not only added new chapters to the textbooks, we were forced to throw out the old books and write new ones. These probes were built to work for 5 years. But even if they had stopped after Saturn, this mission would have been one of the greatest successes in history. They discovered the first active volcanoes outside the Earth on Jupiter. It happened on the moon Io. The moons that we thought were geologically lifeless pieces of rock also have geological action. Or rather, man first realized that many planets have life on their own, and that their volcanoes are working well. They saw lightning in the atmosphere of Jupiter. They discovered a thin, dusty ring of Jupiter that was previously unknown. They gave an indication that there may be a liquid water ocean under the ice layers of the moon Europa. Then there was a decision that determined the course of the mission with Saturn. Scientists had 2 options. Either use Saturn's gravity to guide Voyager 1 back to Uranus and Neptune and complete the grand tour, or send it off course to get a closer look at the mysterious moon Titan. Titan was the only moon in the solar system with an atmosphere as thick as Earth's. They chose Titan because it was a scientific challenge, but a good one. It was a one-way ticket. The path needed to get to Titan was created by Voyager 1 being deflected to the right from the plan of the planet's orbits. That way, Voyager 1 could see other planets in the future. The possibility of visiting the planets was completely closed. At that moment, Voyager 1 was destined to start an interstellar journey. All hopes of completing the grand tour were transferred to its twin, Voyager 2. Voyager 2 arrived at Uranus in 1986 with that hope. In humanity's first and so far only visit to the ice giant, engineers on Earth had to reprogram the spacecraft. They began to teach it new techniques to see in the dark and cold atmosphere far from the sun. So it discovered 10 new moons and 2 new rings. It learned about the strange magnetic field of the planet, which moves as if tilted on one side. Then, in August 1989, it reached Neptune, the last planetary visit in the solar system. With that, the dream of a real grand tour was complete. There, it found a giant storm called the Great Dark Spot, the size of Earth. The fastest winds in the solar system have been recorded on Neptune. It blows at a speed of 2,400 kilometers per hour. Its last mission was a trip to Triton, Neptune's largest moon. There, we got to see the coldest world at the frozen edge of the solar system. A world with a strange surface like the skin of a cantaloupe was most shocking because it was also active. Geysers of nitrogen, ice and black dust were spewing out of its frozen surface, not water. They proved that even at such a distance from the sun, it is a sphere that can maintain complex terrestrial activities. When all the planets were behind, the second phase of the Voyager 2 mission officially began. The Voyager interstellar mission's new goal was to become humanity's first messengers to the stars, crossing the boundary where our sun's influence ends and the vast galaxy begins. That boundary is real. It is called the heliopause. It is the edge of the sun's bubble, the place where the solar wind that pushes out from the sun eventually collides with the cold, dense interstellar medium that flows in the void between stars. On August 25th, 2012, Voyager 1 burst through that bubble and emerged. It became the first human-made object to enter interstellar space. 6 years later, on November 5th, 2018, Voyager 2, traveling in the other direction, followed suit, confirming this was a major challenge. Voyager 1's key plasma detecting equipment had been out of action since 1980, so it couldn't directly detect the change. Scientists had to rely on 2 indirect lines of evidence. First, another instrument detected a sudden drop in the number of particles from the sun. At the same time, it recorded a sharp increase in the number of cosmic rays from outside. This means that the sun has lost its protective shield. Second, the plasma wave detection instrument detected a huge jump in the density of the surrounding plasma, as if moving from thin air to water. This was strong evidence. But it was indirect. The clearest answer was the crossing of the boundary by Voyager 2. Its plasma detection instrument, which provided evidence that everything was still working. That day in 2018, that instrument directly measured the decrease in solar wind and finally stopped completely. It was the first time that humans directly sampled the matter between the stars. And with that, one thing was certain. We had reached interstellar space. That all this is still happening is a marvel of 1970s design and modern engineering. On November 14th, 2023, Voyager 1 suddenly stopped sending data. It was not completely silent. Now it was sending a signal, like a dialed tone from the void, but the signal was half empty. For 5 terrifying months, the spacecraft was deaf and mute. Then came one of the most remarkable feats in the history of remote engineering. More than 25 billion kilometers away, a team at NASA's Jet Propulsion Laboratory began months of industrial detective work. By sending commands and analyzing the garbled signals that came back, they found the problem. A single memory chip in the computer that packaged the data and sent it back to Earth had failed. Because the chip could not be repaired, they came up with a bold plan. They decided to perform digital surgery. They carefully isolated the damaged code, cut it into smaller pieces, and found a way to store those pieces in other empty places in the computer's memory. This is like fixing a damaged chapter in a book. It was like cutting out each sentence from that chapter and writing it in the blank spaces on the sides of the other chapters in the book, and then creating a new index of how to read those sentences in the same order. They had to do all this from 25 billion kilometers away on a 47-year-old computer with 69 kilobytes of memory. The process was very slow because each command and response took 45 hours of travel time, but it worked. The first meaningful signal came back on April 20th, 2024. By June 13th, Voyager 1's 4 scientific instruments were back in action. Data that we could decode and understand began to come in. It was an incredible return. This mission has always been about more than just science and engineering. It is a cultural statement. a priceless mark of humanity. The two probes have the same object attached to the side, a gold-plated copper record. The golden record is a time capsule that could be a message in a bottle if an alien civilization ever finds it in the future. Its contents were selected by a team led by Carl Sagan. It is a picture of Earth in 1977, with the human body, scientific equations, 115 images of life and culture on Earth, the sounds of the wind, the sea, birds and whales, and dialogue in 55 different languages. It also contains 90 minutes of music, from Bach to Beethoven, from Louis Armstrong to a Bulgarian folk song. Sagan himself knew that the chances of finding it were very slim. These spacecraft would have to travel 400,000 years to even reach the next star system. He always said that the true audience for this golden record was humanity. The act of choosing the sights and sounds of our world was a statement of hope, an opportunity to reflect on ourselves. And then there was that last photo, the pale blue dot, in 1990. On Valentine's Day, as it completed its primary mission and headed away from the solar system, Voyager 1 was given one last command. As Carl Sagan had repeatedly requested from NASA, the spacecraft turned its cameras one last time toward its home, 6 billion kilometers away, to take a family portrait selfie of the solar system. This image was not a scientific necessity, it was a philosophical necessity. It means a perspective in one of those frames. Earth appears as a tiny dot of light, like a speck of dust, not even a pixel in size, caught in the sunlight. The end of the Voyager mission is not an isolated event. It is a slow process that we are witnessing now. It is expected that by about 2030, none of the remaining scientific instruments will have enough power to operate. Then, perhaps by 2036, the spacecraft will be able to send a tiny heartbeat signal that tells us it is still there. There may be only electricity, then, at some point, the last signal will fade. The probes will be silent forever. But once they are silent, their physical journey will only begin. They are traveling too fast to escape the sun's gravitational field, so they will never return. They are not leaving the Milky Way. They are entering their own orbit around the center of the galaxy. They have not yet completely left our solar system. Then it will take tens of thousands of years to pass through that dark cloud. Only then will they truly break free from the sun's gravitational field and begin their journey as interstellar objects. They will float in that void for millions of years, silent ambassadors. They will outlive us all. The Voyager missions began 2 years ago, carrying a golden record as a silent testament to the species that built them. A 5-year journey to the planets has now evolved into a journey of more than 48 years. So thank you, NASA. Thank you for this Voyager mission. This is a tribute to the brave mission that began 48 years ago so that our generation can know stories like this, like a documentary.